Okay. Well, let's go ahead and begin. Um, I'll double check just because I'm not 100% sure using this new setup. Can you see the announcement slide just fine? Is that coming through on your end?
Yep.
All right. Thank you. So, thank you. The next homework assignment, number 8, that is due on Monday the 19th, and I think that we took a look at that briefly after our class on Monday. So it's posted now, and you can get started on that. And then also the project deadline is getting closer with every passing day. And so I had a student check in with me yesterday. They sent me their spreadsheet just for like a quick check and some comments, and I was glad to do that. And I hope to receive more of those messages and Teams calls in the future if you want to go over some of the details and assumptions you're making for the project. I'd be happy to discuss it with you. So today what we're going to do is we're going to learn a new technique called incremental analysis, and we're going to apply it to rate of return. So before we start talking about incremental analysis, does anybody have questions? All right. By the way, on the topic of the project, it's important that your expenses should go up over time. And it's common in a lot of jobs that you'll have an annual cost of living adjustment as well. And so wages go up each year to try and keep pace with inflation. And my common recommendation to students is that you have a separate factor, like at the top of your spreadsheet, you have a value that tells you what the inflation rate is each year. And so your expenses are going up every year because things just naturally get more expensive. They're also going to go up because maybe you have more household members. And so as your family grows, your cost of food will increase, your cost of insurance and housing, all those things will go up if you have more people in your family. But then the other way that they go up is simply because of inflation. So in your project, it should reflect both the fact that you're going to be getting a little more income each year and also your expenses are going up. Now, I sometimes get questions from students about how specific you need to be in developing an analysis of your expenses. And what's not okay is to just pick some round number as a budget and say that I'm going to set aside $500 a month for rent and $100 a month for utilities. That's not a sufficient level of detail. Because what I'd rather that you do is identify a specific apartment that you would be renting rather than just allocating a budget. Look at the things that you need and how expensive those things genuinely are. And so, to find a specific apartment, to identify the cost of your utilities in specific. And so you may already live on your own and know what a water bill and a cable bill and electric bill costs, or you can get some of that information from family members or friends. But then in the case of food, for example, rather than just saying how much you spend on food each month, take it down to an additional layer of detail where you look at the specific items and how much you'd allocate on a weekly basis maybe would make more sense than on a monthly basis, because very few people would buy a month's worth of food all at once. Unless maybe you live out in the tundra of Alaska and that's only how often you get into town. Probably you're going to be stopping by the shops quite often, and so what you should do is just look at how much you'd spend on a weekly basis and then multiply that by 4 to get your monthly cost. So
Somebody has an issue with that one. Look at that list. When you spend more money on beer than food.
that's a joke,
Their
right?
priorities are in order.
Right, exactly. Yeah. I'm glad you noticed that. That shows you're paying attention. Very good. All right. All right, so this is incremental analysis. First of all, the way that you determine an incremental cash flow is you're comparing two alternatives. Here we have option A and option B. And so both of these options have an upfront initial cost And there's a certain amount of money each year that is spent to maintain and operate these items, and then at the end of their useful life they'll have a salvage value. So here we're not really looking at the profits that they generate, but just the factors that would maybe determine the cost of buying and servicing this equipment. So in an analysis of A versus B, the increment is the difference between the two. So when I talk about the increment, what I mean is that you should have the more expensive alternative and subtract the less expensive alternative. So the incremental cash flow is that option B, you can see, is $20,000 more expensive, and there is a reduction though. The annual cost is $6,000 in the favor of option B, because option A costs more upfront. Excuse me, option B costs more upfront, but option A costs more on an annual basis. And then of course option B also has more salvage value. And so this increment is just saying how much different is the cost, how much different is the salvage, and then sometimes we'll also look at the difference in the revenue that can be generated. But the main idea that I want to introduce at first is the idea of the increment, and what it means is the difference between two alternatives. And our common approach is to put the cheaper alternative on the left when we're making tables, the cheapest alternative on the left, and then start sorting them in order of increasingly more expensive. The increment is the difference. Now, whether to go with option B is determined by analyzing the rate of return on the incremental cost. So, you know, the question that you would be wanting to solve in an incremental analysis is, should I buy the more expensive option, or should I just get the thing that's cheaper? And you face questions like this all the time. For example, when it comes to a car, you may have one vehicle that's relatively more expensive, but you expect it may have a lower operating cost. So, you know, should you pay a little extra for the Toyota, or should you spend a little bit less for the Chevy? And the way to answer that question is you analyze the rate of return on the increment. The extra $20,000 in this case, the additional cost to buy the more expensive alternative, that is what you're going to analyze. You're going to say, what's the rate of return on that additional investment? And if it's greater than the MAR, then that tells you you should spend the additional money. So here's just another illustration. Option A versus option B. You can see that in this illustration we've identified the minimum attractive rate of return is 10%. And so anytime the rate of return is greater than 10, then that means the project is potentially suitable. And you can see that both project A and project B are suitable because they both have internal rates of return that's greater than the MAR. So either option is going to give you profits. And in fact, if you discount the cash flows to the present, they both have a positive present worth. Now in our in-class example on Monday, we tried to do an illustration having to make the point that you don't pick the option with the highest IRR, you pick the option with the greatest profits. And so you can see here it's highlighted that option B has more profits when you discount the cash flow at the MAR. Even though option A has the higher internal rate of return, you still, in this case, A versus B, you would choose option B. But sometimes you may be curious to know the extra $13,000, because if you have B versus A, you're going to spend an extra $13,000 to get option B. The question might be, what's the rate of return on that additional $13,000? And so that's where you do an incremental analysis, and you'd subtract B minus A for each of the rows. So the initial additional cost is $13,000, and the additional revenue each year, $4,225. And so if you do the IRR function on this range, the B versus A, you're not seeing my cursor today, are you? Can anybody see my cursor right now moving around?
No.
Oh, okay. Well, let's see. What if I do this? No, that's not working either. All right. Well, I'll have it back by Friday. So I was just saying, if you look at this third column, oh, maybe now you can see it, right?
Yeah, it's better
Okay,
now.
that's very strange. Okay. 13,000 extra yields a return of 11.4%. And so the decision criteria is if the rate of return on the difference exceeds the MAR, then you should choose the more expensive alternative. And you should maybe write that down. The decision criteria is if the rate of return on the additional amount exceeds the MAR, then you should spend the extra amount. So here, option B is justified because you're spending an extra $13,000, and that additional $13,000 is making 11.4%, and that's greater than the MAR of 10%, and so we should choose option A. Excuse me, option B. We should spend the extra amount. So if the internal rate of return of the difference, meaning the increment, is greater than the MAR, then the additional investment is justified. Now, the letter I has been thrown around quite a lot this semester. And so this slide just kind of clarifies the different variables that we're going to use for different interpretations of the letter I. There's a question here, what do you do if you have vehicles with different life expectancies, like Tesla versus a gas car? In a case like that, then you'd need to use the repeatability assumption or early termination or contract services to make them the same duration before you could do the incremental analysis. Good question. All right, so capital I means the interest amount. And so the interest amount is related to the initial principal that's borrowed in the case of a loan, and then the interest rate that's applicable. So capital I would have units of dollars. Lowercase I means an interest rate, and that's where it's expressed as a percentage per time period. And by far the most common time period is for us to express the rates on an annual basis, even if compounding occurs more or less frequently than on an annual basis. It's still common to express it on an annual basis. Now, I star means rate of return. And I star is often what we're going to be solving for if we're doing, for instance, internal rate of return calculation. That's where you're assuming that the earnings can be reinvested. So the rate of return brings a balance between the inflows and the outflows. I prime is the external rate of return, which we talked about Friday last week, and then also practiced on Monday, the external rate of return. And that's where the earnings aren't reinvested into the same project, and instead they have to be put into a different location, an external account that has a separate external reinvestment rate. Now, speaking of external reinvestment rate, the variable we use for that is I sub I. And so that's, for instance, if you own a company but the profits from that business go into a different savings account, whatever the interest rate paid by that other savings account is what we would assign the I sub I variable. Now finally, the one that we're introducing today is delta I star. And so what that means is it's the rate of return on the difference between two options. So the delta means the increment, and we're going to be analyzing the rate of return, meaning the internal rate of return, on the increment. Okay, now here's an illustration. We've already done an incremental analysis illustration with two options. But sometimes it's more complicated than that. In this case, we're going to compare 5 options. And you can see up at the top of the screen that the minimum attractive rate of return is 18%. And so the first thing that we'll do for initial screening purposes is we'll try to identify if all 5 of these options are suitable. And so we have our initial cost, there's the revenue for each year, and then using the IRR function with the entire range, the IRR function, what it's going to... Is there a question? Go ahead. Harry, did you have a question? No? Okay. Thought I heard something. All right, so you do the IRR function on the entire cash flow, and you can see for option A it's 26%, and so since that's greater than the 18% minimum, it passes the initial screening. And so we do that for all 5 of the options. Now, you can see that there's different colors here, and that's because we do the incremental analysis in phases. We only compare 2 at a time. We don't know yet what all of the comparisons are going to be. It's kind of like a matchup or a contest. And the first contest is going to be B versus A. And the reason why the first contest is B versus A is we start with the cheapest one on the left. You'll notice that these are all sorted in order of increasing cost. And so in B versus A, we're going to ask the question, is it worth spending the extra $12,000 to get option B? And the principle that you're going to apply is you should always spend an additional amount as long as the rate of return on that additional investment is greater than the MAR. And so this extra $12,000 to get option B, what's the rate of return on that $12,000? So let's look at B versus A. So we've got the extra $12,000 each year, the $12,000 initial cost, the $3,100 additional revenue each year, and if you do the delta IRR, so that's the rate of return on the increment, then it's 22%. And so what that means is that you could be satisfied with option A. Option A will do the job. And option B costs a little bit more. And what if you're going to have to borrow the money in order to get option B? Well, even if you give 18% to whoever you borrow the money from, you're still going to come out ahead because you're earning 22% on the increment. And so you'll be able to pay off the loan and still keep more if you go with option B instead of option A. So you can see here on the decision row, our decision is the delta IRR is greater than the MAR, so we should accept B. So after the first matchup, the first comparison, our new champion is option B. And so the next matchup is going to be C versus B. So let's do that now. C versus B. You can see it only costs an additional $5,000 for option C, but yet we get a big increase in the revenue each year, $2,200. And so the rate of return on the additional $5,000 is 43%, and since that's greater than the MAR, you accept option C. And so now option C is the champion, and all of the future matchups are going to be the next matchup is going to be against the current champion, which is option C. So for our third matchup, it's D versus C. So that's an extra $5,000, but it only generates an additional $500 per year, which is actually a 0% incremental rate of return. So D is no good. We wouldn't choose option D, and so that means we keep option C in that comparison. And then the final comparison, where we're going to look at option E, don't compare E to something that you just rejected. You just rejected D, so it's out of the running completely. So what that means is the final comparison is E versus C, because C came out as the winner in the third comparison. And so this last column is E versus C, and you can see that it only yields 14% rate of return, which is less than 18. So that means that E fails and C is the overall winner. And so it's the option that's going to give us the highest profits. And we also know what is the rate of return incrementally. So this is just another way for us to choose alternatives, to know which option is going to yield your company the best benefit. So is there any questions about the procedure that we went through on that incremental analysis? Okay, so here's the in-class exercise for today. We have a couple of options. There is some asphalt. We need to get a new asphalt compactor. You can choose from an option made by Caterpillar, one that's made by Komatsu, Volvo, Hitachi, Deere, and Atlas. You'll notice that when I gave you this list, it's not in the order that it needs to be for incremental analysis. If we go back to the template for an incremental analysis, what you should do is you should sort it so on the left side is the cheapest and increasingly more expensive. And by the way, these options were called A, B, C, D. In this example, don't call it A, B, C, or D. Call it C, K, V. You know, these they're actually like the letter that corresponds to its actual name. So what I'd like you to do is follow the same procedure that was illustrated in this setup, where you need to translate this table into a diagram that looks like this, where each row has its applicable revenue. And then below that, calculate the internal rate of return and do the initial screening. So question A is, are there any of these options that we should just reject outright even before performing the incremental analysis on the basis that their internal rate of return is less than the MAR? And so I think you'll find that at least one of the options should be rejected because its IRR is less than the MAR. And then of the options that remain as acceptable, then list them in order of least expensive on the left to more expensive on the right. So that's just kind of sorting it according to this same procedure. And then perform the incremental analysis. And remember that at the beginning, you don't know all of the matchups. It's only one at a time that you're going to do. So it's going to be B versus A, and you can't set up all of the columns over here to the right at the beginning. Like at the beginning, we don't know that it's going to be A, B, B, C, and so on. You only know one column at a time because you don't know which alternative is going to prevail in the first comparison. Okay, so in doing the incremental analysis, what that'll tell you is which option is best. And then we also will be able to know what's the incremental rate of return compared to the second best alternative. So for example, in the previous illustration, the second best alternative, when we did the comparison of B versus C, C was the best alternative, and it yields 43% return compared to the next best alternative. So the rate of return on the increment was 43%. So it's that part of it that I'm asking you to find here in the last bullet point. Okay, so what I'll do is I'll make this a little bit smaller in case you don't have it printed so you can see it at the same time that you have this example on the screen. Hopefully you'll be able to see a little bit about both. Let me delete all of these. Okay. So we're going to repeat this same illustration with the actual numbers on the in-class exercise, and I'd like you to determine which alternative should be selected by doing this incremental analysis. And so what I'll do is I'll pause for a moment, and then after I give you some time to get a head start, then I'll start solving this without any narration. And so I'll let you know when I'm going to start that in case you're completely stuck and you just want to watch me go through it, then you can do that. But in case you are still working productively, then I won't narrate because I'm worried it may distract you. So I'll give you a few minutes to get a head start, and then I'll go through the illustration as well. Okay, just to let you know, I am going to start working on the solution. So if you're making good progress, continue on. But if you want to watch what I do, then that's fine as well. By the way, if there's a certain thing that I do and you want to know how or why I did it that way, feel free to interject with a question. I'm happy to pause for a moment and explain something if you need the clarification.
Dr. Wade.
Yes, go ahead.
So D was rejected initially because
K was rejected
actually,
initially.
K was.
Yeah.
K, okay.
And it was rejected initially because the IRR of it overall is less than the MAR.
Yes. Okay.
Okay, so I finished the solution. I'm gonna pause for a second for you to have a look and compare it to what you've been working on, or if you need to make some changes and updates to finish that. And then we're gonna do one more thing, one more point of analysis. But while I pause and allow you to keep working, if you do have questions or if you find a mistake on yours and you're wondering what the issue may be, please let me know. All right, well, let's talk through this analysis. Let's take a look at the details just to make sure that we understood. So the first thing that we did was the initial screening. And we put up all of the options in order. And I know it takes a little bit of extra effort to put them in order compared to the arrangement of the original data, but it's worth it. It'll save a lot of confusion when you're doing the incremental analysis. And so please always do sort it with cheapest on the left and increasingly more expensive. And so the IRR function was done on each one of these options, and you can see that all of them passed muster except for Komatsu. And Komatsu only has an internal rate of return of 8.9%, and since that's less than 12, it's not suitable. All of these other options, it's greater than the MAR, and therefore they're suitable. Now that doesn't mean that we know yet which one is best, and the one with the highest internal rate of return isn't necessarily the one that's best. And in fact, you've already seen what the overall answer is. The overall answer is that Hitachi is the best. But Hitachi isn't the one with the largest IRR. So that's part of the reason why we need to do the initial, to do the incremental analysis. So the first matchup is going to be cat versus deer. And the reason why it's not Komatsu versus deer is because Komatsu was rejected in the initial screening, so it's out of the running entirely. So here is the incremental cost and the incremental revenue, and then the incremental internal rate of return. So it's still just the regular IRR formula, but you're applying it to the increment. And since the rate of return of 11.2% is less than the MAR, that means that you should reject the more expensive alternative. In other words, it's not worth it to spend $25,700. It's not, that extra amount isn't worthwhile because the additional revenue that it brings isn't enough to justify that additional initial cost. So we reject cat and we keep the deer alternative. And so the next matchup, if we look at our list, we're working towards the right. The next option is Hitachi. It's the next most expensive alternative compared to what cat was. So now the next comparison, Hitachi versus deer. And here you can see the column Hitachi minus Deere, and the rate of return that we get there, 18.6%, tells us that it is worth spending the extra $33,000. That additional $33,000 is earning a return of 18.6%. So if you can go to a bank and borrow money at 12%, and then you earn 18% on that money that you just borrowed, you should absolutely take that deal. So we go ahead with Hitachi. That's our next winner. And so the next comparison is Volvo versus Hitachi. We're not comparing against Deere anymore because we've moved on. So Volvo versus Hitachi has a negative internal rate of return. That means we don't make back the initial $15,000 in added cost. This measly $700 per year doesn't even come close to covering it. So we reject Volvo, and our last matchup, Atlas versus Hitachi, only earns 6%, and that's also less than the MAR. So we reject Atlas and we choose the Hitachi. So does that make sense to everybody? Does the flow of the work and the logic behind the decisions make sense? Any questions that you'd like to ask about that? You know, if you're going to be making a PDF of this or printing it, it pays to take a little bit of time to format it. Let's do one more check. Now this said that Hitachi is best. Hitachi is the best alternative. We have another way to know which alternative is best, and that is the present worth method. We can do the present worth method and we'll get the same answer. So let's do that. Let's use the NPV function. NPV. Just to verify which alternative is the most profitable. Now, what I hope you remember about the NPV function is that you should only put amounts into that function that are in the future. If an amount is already at the present, for instance, like this $22,000 cost, it shouldn't go inside the NPV function. So what we're going to say is equals NPV, and now it's asking the rate. So let me refer up here to the location that has our 12% interest rate. And then it's asking me to tell it the values. So I'm only going to put the values that are in the future, not inclusive of the amount at year 0. So that will discount all of the revenue to the present. And then outside of the NPV function, I need to add in year 0. Since year 0 is already at the present, it doesn't need to be included in the NPV function. So the overall net present value, when we discount at 12%, is $10,771 for Deere. And so it's acceptable. Anything that has a positive present worth when you're discounting at the MAR is an acceptable alternative. But if we apply this sideways, we're going to see, for example, that the Komatsu option is a rejection because it doesn't break even for the Komatsu option. But the highest, the best alternative, is the same one that we identified through the incremental analysis. The Hitachi is the most profitable option. And so it's another way of double checking the results of our analysis is by finding the present value of each of the alternatives. Okay, so this incremental analysis is really important. We're going to do incremental analysis a couple of times this semester in different contexts, so it's not going away. You have to figure this out. It's very important. So if you do have uncertainties or questions, then please let me know. Let's just look at the announcements one last time before we go our separate ways. I think that the two things that you've got on your plate right now are the homework assignment, which is due on Monday next week, and then the project, which is due the Friday before Thanksgiving. That's all I have for you today. Hope you're doing well, and I'll see you on Friday.